Hi, my name is James Mcclendon. I've been asked for several years now to do a video on how to make a crane cable knife. Before we start, we're going to talk about the do's and the don'ts and what you look for in your cable. The first thing, most of us are going to use cable that's been used. These will come from crane cables where they've changed the cable out. These will come from old chokers that loggers would use. The first thing that you're going to look at with your cable is what it's made out of. If it's stainless steel, throw it away. You will not be able to use stainless steel cable. If it's galvanized, the galvanized cable is coated with zinc, and zinc is very toxic. If you're unsure and you put this cable in the forge and you see this kind of wispy blue white flame coming off of it, take it out and get some fresh air, because that is a sign that there's zinc present. The next thing is the size of the cable. It's not only the size of the cable. You take this piece right here, which is about a ½ inch, but it's also the size of the individual strands. I'm told that when the cable is made, when they make the individual wire, the wires are ran through dies and it decarburizes. This amounts to 0.010 or 10 thousandths the total diameter of the wire. So if you're running a wire that's the individual strands that are 020, you've lost half of the carbon to decarburization before you ever start, which means if that cable was 1% carbon when you started, it would be 0.5% carbon. And the sad truth is that cable is not 1% carbon. Most of your cable that you're going to run across is either IPS, extra IPS, or if you're fortunate to find it, extra IPS. The IPS stands for improved plowshare, which means the cable is 0.65% carbon. Extra IPS, which is the most common, is going to run 0.75% carbon, but that even varies within the run on the wire. I've seen pretty much a lot of variance from one end of a piece of cable to the other and how it reacted. The other thing you look at is, take these two pieces right here. They're almost the same diameter, but you'll notice that the one in my left hand has a much finer wire. This wire is what I'm talking about as far as carbon loss. When you weld this up, it'll be pretty much useless as a cutting tool, because the end product's probably going to be about 0.3% carbon. It'll barely harden in a water quench. So what you want to use is a large wired cable, and we'll start welding up next. Okay, now that the forge is up to temperature, we're going to talk about making your first welds. You'll notice that I don't fuse or weld the ends of the cable. I found that it's really unnecessary. If you do the proper steps, you can weld it up in the forge with absolutely no problem. We're going to put it in the forge now and make the first weld. Okay, when the piece comes up to a red heat, cover thoroughly and rather liberally with borax. A lot of mistakes that are made when welding cable is you don't get enough coverage. There's a lot of surface area there to cover. Bring it back up to heat now. Okay, when the piece is up to welding temperature, kind of take it off and set the weld. I should note that I always flux twice. And the main reason why is the flux not only cleans the weld, but it also acts as a heat sink. Many times why weld fails on a piece of cable is that the core is not up to temperature, and so the flux coats and it takes the heat to the center. We're going to start the weld with a light hammer. This is a 2-pound hammer. Start with light hammer strikes. You'll see the weld start cinching down. As the weld cinches down, then the hammer strikes can become harder. And I'm going to square off the end. Let's go do the other end now. Okay, now we're ready to set the second weld. Light hammer strikes till the weld sets. And we're squaring it off. Now we're going to flux the whole thing. Face. It's ringing out like a basketball now. Set the weld. Good now. Just brush it off, reflux it to the torch. Okay, the billet's up to temperature now. We move to a 4-pound hammer. Unlike most pattern welded billets, you use too heavy hammer on those, the weld will slip. The cable is different. It really does well to set the weld with a heavy hammer and hard blows after you twist it this way. We're going to square it off now. Start at the end and work our way down. Like ironing it out. For another heat. Continuing the welding process. Okay, we've got a good start on the billet now. At this point, if you wanted to just go ahead and flatten it out and form the blade, a billet like this would make a blade about an inch tall, suitable for a good working knife. Have a nice twisting pattern running through it. But what I'm going to do is I'm going to hot cut it in the center and fold it over back on itself. Now that we're up to temperature, I got my hot cut party. Good heavy hammer for this procedure. You want to locate the center or thereabouts. Hot cut. Fold it back on itself. it off good. Give it a good flux and bring it back up to welding. Set the weld. Start on the end. Another coat of flux, the next heat and weld should be good and set. Alright, I'm ready to repeat the weld this time. Real heavy hammer. Okay, the belt's pretty much set. Now, the next thing I'm going to do is I'm going to weld a handle onto the end. This will make it easier for me to hold on to. It's kind of a hard time doing it. You don't necessarily have to do this, but it's something I'm going to do.